Today we're going to be looking at Chapter 23, Section E, on calculating probabilities using permutations and combinations. Let's go all the way back to Chapter 11 and review what probabilities are. But this time we're going to keep it in the context of permutations and combinations. We'll start with our now common example ABC. Let's write out all the different permutations of ABC. So again, for permutations, order matters. So I can write ABC as ACB, BAC, BCA, CAB, and CBA. Using our formula for permutations, I can check that. I have three symbols, and I'm going to take all three of them. So the first symbol I have three choices, the second symbol I have two choices, and the last symbol I have one choice. Using the product principle, I multiply those together and I get 6 permutations. Let's say that these letters were written on Scrabble tiles, and that those tiles were placed in a bag. What's the probability that I would choose 3 tiles in the exact order BCA? So if I was to choose these tiles out of a bag, what's the probability that it would be in the order BCA? Well, remember that probability is simply the number of ways that we can get a specific outcome like BCA. In this example, there's only one way we can get it, divided by the total number of possible outcomes. Well, there's 6 total possible outcomes, so the probability of drawing BCA out of a hat of 6 tiles would be 1/6. Let's write out a more formal definition of probability just to refresh your memories. So the probability of an event occurring is the number of possibilities with the required properties of an event simply divided by the total number of possibilities, or unrestricted possibilities. We covered this information fairly well in Chapter 11, but now we're going to use permutations and combinations, and it can get a little bit tricky because often we're trying to figure out which to use. Should I use a permutation or a combination? So keep this in mind. Permutations deal with orderings. Right? In this case, order matters. For example, ABC is different than BAC. Often we're looking at permutations when we're talking about objects or things. Combinations, on the other hand, deal with selections. And here, order doesn't matter. And we often use combinations when we're talking about people or committees or selecting teams, things of that nature. So if I select 3 people, it doesn't really matter which order I select them in. It matters who they are in the end. So let's take a look at a couple of examples. In the first example, we have a team of 6 being randomly selected from a squad of 8 boys and 7 girls. The question is, what is the probability of getting 3 boys and 3 girls? The very first thing that we should do in these types of problems is figure out whether or not we're going to use a combination or a permutation. Now, because we're talking about selecting a team of people, we know from the previous slide that we probably are going to use combinations. Remember that the probability is simply the total number of ways that we can get a specific outcome divided by the total number of unrestricted outcomes. So in this case, we want to get 3 boys and 3 girls. The total number of ways to select 6 people from a squad of 8 boys and 7 girls can be found using this combination, right? There are total 15 people. And I can select any 6 of them. These are the unrestricted cases. If you plug this into your calculator, 15 NCR, remember this notation from the last video, times 6, you should get 5,005. I also want to quickly review how you can write this using factorial notation. This would also equal 15 factorial over 6 factorial times 15 minus 6 factorial, which is 9 factorial. And again, if you use your calculator, you should get the same answer. I could write out 15 factorial, but it's a really, really, really large number. So you want to get in the habit of using your calculator wherever possible. Plus, it would take you a lot more time to type in 15 times 14 times 13 times 12, and so on. So again, you should be using your calculator. So we found the total number of possible ways to get 6 people from a group of 15. But now we have to look at selecting only 3 girls and 3 boys. So remember, I have 8 boys to choose from, and I'm going to take 3 of them. This is one combination. And using the product principle, I'm going to multiply that by the number of different combinations for choosing 3 girls out of 7. Again, if I use my calculator, 8 NCR3 times 7 NCR3 is going to get us 56 times 35. Now that I know all the components of this expression, I can plug that into my calculator to find the overall probability, which is 0.392, or 39%. In the second example problem, we're going to use permutations instead of combinations. Let's read through the problem. We have the letters T, A, E, M, and S, and they're placed at random in a row. Think again of our Scrabble tiles. What is the probability that they spell out teams or meets when they're placed in a row? Okay, because we are talking about things, in this case, letters, and order matters because we need to spell a word, teams or meets, I'm going to use permutations. So the probability of spelling teams or meets is 2 over 120. And this comes from, there are 2 outcomes with the requirements that I'm looking for, over 120 total possible permutations. Remember from the beginning of the chapter, to find the total number of permutations for 5 symbols, I can set up 5 boxes. I have 5 different letters that I can place in the first box. Once I choose one, I only have 4 letters. 3, 2, 1, using the product principle. This gets me 120. This is the total number of permutations that I can have for the letters T, A, E, M, and S. So again, we're using what we've already learned to just take it to the next step to find probabilities. Again, be really careful whether or not you're using permutations or combinations, and we'll practice again more next class.